Hello students. So we are doing application of derivatives. Some board questions. Okay. Um, so today we are going to solve problems on increasing or decreasing functions. So in this, if you are given a function, you have to find the derivative of that function. Then you will get the critical points. Okay, equate it to zero. The derivative you have to equate it to zero so that you will get some values of x. Those values you have to put into f dash of x and see the sign. Okay. If it is negative, then the function is decreasing. If the sign is positive, the function is increasing. This is because when function is the function is if it is strictly increasing, okay, then the derivative is greater than 0. Okay. If it is only increasing, then we have to include also equal to 0. When derivative becomes equal to 0, when the function is constant, right? Whenever it is a constant function, so suppose there is some constant function and then it is increasing, then we can say that it is only increasing. It is not strictly increasing. Strictly means greater than. Okay, we'll do some examples so that you can practice those examples. Let's solve this. So f of x is given. Okay. You have to find the intervals on which it is increasing or decreasing. Okay. So its derivative you have to use the UV rule. This is u, this is v. So u dash square, its derivative is 1 plus, again the derivative is 1. Sorry, I have to write v also, plus v dash and u. Okay. Now in this you can take common 3. Also you can take common x plus 1 square. Okay. And x minus 3 square. So inside you will get here only x minus 3 is there and here x plus 1. So this becomes 2x minus 2. So you can take 2 also outside common. So 3 into 2, this becomes 6. Okay. So when I equate this to 0, I will get the critical points, that is x equal to minus 1, x equal to 3 and x equal to 1. So now we have to draw the intervals. Okay. 0, minus 1, 1, 2 and 3. Okay. So from minus 1 to full this infinity, that is minus infinity to minus 1. This is our first interval. Then from minus 1 to 1. Okay. And then 1 to 3. And one more is there. 3 to infinity. So 4 intervals are there. Okay. Now let's check the sign of f dash of x when we put some values from these intervals. Okay. So I'll write f dash of x here. Let's write the intervals. Okay. Now we have to check the sign. of f dash of x. So if I put some value, suppose -2, okay. Now look here, this is square, this is square. This is square, this is square. So both will be positive. Any number you put over there, it will be positive. You have to check only sign of this, okay. So we are taking a negative number, suppose -2. So this will be in negative. So the total sign is negative. So this, in this, the function is decreasing. Okay. What about this -1 to 1? So I'll put 0. First two are positive. I'll write it for all. So the last one, if I put here 0, 0 minus 1, so negative. Right? Decreasing. Okay. For 1 to 3, again these two are positive. If I put a number, say 2, 2 minus 1, so this is positive. Positive. So it is increasing. Okay. What about 3 to infinity? Again, the positive number, so we will get a positive. So it is increasing. So the function is increasing in the interval 1, 3 and 3, infinity. Okay, and it is decreasing. Here the thing is, I'll write it down, strictly increasing. Okay, function is strictly increasing. That is, f dash of x is greater than 0 in the interval 1, 3 and 3, infinity. Okay, same way you have to write for strictly decreasing in the interval minus infinity to -1, -1 to 1. Now, second thing is, if it is asked only increasing, okay, function is only increasing, then this will be greater than or equal to 0, and for increasing we have to include this 1 and 3, because at these 2 points the function is becoming 0. F dash of x is becoming 0. Okay, so we have to make it a closed interval. This becomes 1 to 3, 3 to infinity. Please keep this in mind. Okay. For strictly increasing, we have to write the open intervals. For only increasing or decreasing, we have to write the closed intervals. That is, we have to include those points. Okay. Next question. Find intervals in which the function given by fx, that is sine of 3x, okay, and where x belongs to 0, pi by 2. Here the interval is given, okay. Now increasing or decreasing, that we have to find. Okay. Same steps you have to follow. So first you have to find f dash of x. So sine 3x becomes cos 3x into derivative of 3x, that is 3. So 3 cos 3x. Okay. Next thing, we have to put this equal to 0. Okay. So cos 3x is equal to 0. Now at which points, that is at which angles, this cos 3x becomes equal to 0. So we have cos of values 0 degree, it is 0, 1, 0. So for pi by 2, okay, cos of pi by 2 is 0. Okay. Then again for this is pi by 2, right? Again for 3 pi by 2, it is 0. Okay. So 3x should be equal to pi by 2, or another point can take 270, that is 3 pi by 2. For these two values it is 0. So our x is pi by 6 and pi by 2. Okay, these are the points. Now interval is given. On that interval, we have to plot this. 0, and this is 90, right? 90 degree, and this is our 30 degree. So 30 is there, 60 is there. So this is 30 degree. Okay, so it is between 0 to pi by 2, pi by 6. Now we have the intervals, that is from 0 to pi by 6 and pi by 6 to pi by 2. So we got two intervals, right? 0 to pi by 6 and pi by 6 to pi by 2. 0 to pi by 6 means this is from 0 to 30. Okay, this is 30 degree, this is 60 degree, this is 90 degree. So we have this interval and this interval. Okay, let's check for the point 0. So if I put, where is f dash of x? 3 cos 3x, right? So if I put here 0, cos 0 is 1. Okay, so for this point, f dash of x is increasing, that is greater than 0. Okay, so if they have given, say, to find strictly increasing interval, okay, then you have to include this 0. Okay, for this we have to remove this pi by 6 because at this point it becomes equal to 0. F dash of x becomes equal to 0. So you can write like this. For the interval, say f dash of x is greater than 0 for x belonging to including 0 and removing pi by 6. So for this interval, it is strictly increasing. Okay. Now let's see this interval. Now for pi by 6 and pi by 2, if I put in f dash of x, both the points will get it equal to 0. So we can take one point, that is 60 degree, pi by 3. So cos 3 into pi by 3. So we'll get cos pi is minus 1. Here it was 3, right? So we'll get minus 3. So for this, that is the point which is between these two points, we are getting function strictly in decreasing. Okay, so we can write like this. F dash of x is strictly decreasing for the function pi by 6 open intervals. That is, we are removing both this because at this both the points it is 0 decreasing. Okay. Now if you want to write for just increasing, that is f dash of x is greater than or equal to 0, then we can write for x belonging to, we have to include both these points. Okay, let's solve for this. So we'll find all the four things, that is strictly increasing, decreasing, increasing and decreasing. Okay, start with the derivative. Cube 12x square, and this is 0. So putting it to be equal to 0, taking common, okay. Now here sometimes students do one mistake, that is they do not consider, that is they'll consider only this thing, that is x equal to 12. Okay, you have to consider this also because it is a part of that function. Okay, we are equating this term to 0 and also this term to 0, that is OR. right? So you'll get x equal to 0 and x equal to 12. So these are the critical points. Okay, so we have the interval. You can draw. It is from minus infinity to 0 and 0 to 12 and 12 to infinity. So three intervals are there. Okay, I'll write here intervals minus infinity to 0, 0 to 12 and 12 to infinity. Okay, sign of f dash of x. So for this, if I put minus 1, okay, this will be negative minus 1 square. Square means this is positive. Okay, so you can write here positive. Minus 1, so this is negative. So you will get negative. So it is decrease. Strictly decrease. What about this? 0 to 12. If I put here 1, again negative. Strictly decreasing. What about this? So if I put here 13, positive, increasing. Okay. So on this three intervals, on this 2, it is strictly decreasing. On this, it is strictly increasing. What about the only increasing or decreasing? So f dash of x is greater than or equal to 0 for the intervals 12 you have to include. Okay, and it is only decreasing on the interval 0 union. This way also you can write. Okay, the students. So we are doing some board questions and also revisions. This is local maxima and minima, that is from application of derivatives. Okay, so to find local maxima or minima, we have two tests. Right, first is that is first derivative test and second derivative test. Okay, for first derivative test, if the function is given, the function is given, then you have to find the f dash of x. Okay, equate it to 0, you will get the critical points. Some x equal to something or this. Then you have to plot it. Okay, suppose this is your x1, this is your x2. Now you have to put some value from this area, that is some point 1 something. Okay, that is from the left hand side and from the right hand side. And then you have to see the sign. If this is positive, this is negative. Okay, again for this point also, it is say you are getting negative and positive. Okay, now you have to put those values in f dash of x, then only you will get this sign. Okay, so here your f dash of x is changing sign from positive to negative. Okay, whenever it is changing sign from positive to negative, then we say it to be local maxima. That point, this point is local maxima. Okay, so then you have to put that point in f of x and you will get the maximum value. Okay, for this, that is, it is changing sign from negative to positive, right? So this will be local minima. if sign is not getting changed, that is, it is remaining positive to positive or negative to negative, then that point is called point of inflection. Okay. So let's solve some problems so that you will understand it better. Also, I'll explain second derivative test. For second derivative test, you have to first find out f dash of x, put it equal to 0, you get the critical points. Okay. Again, you have to derive. Okay. Now you have to put these points in this. Okay. If it is greater than 0, then this is minimum. If it is less than 0, then it is maximum. Okay. Let's solve one problem. I'm taking question from the textbook. So finding out dash of x, put it equal to 0. So we'll get x equal to -1 and x equal to 1. Okay. Now, so we have to take one point from this and from this. Okay. So starting with, suppose I'm taking some point, say -1.1, and from here I'm taking -0.9. From this I'm taking 0.9. From this I'm taking 1.1. Okay. Let's put this point over here. This you can write x minus 1, x plus 1. So if I put -1.1, okay, here also you can put, it will become positive. So this is positive. What about this? So also positive, but the number will be in square. Better you put here only. Okay. -1.1 minus 1, this is negative into negative, so positive. Then -0.9, negative, positive, so negative. 0.9, negative, positive, negative. 1.1, positive, positive, so positive. So here f dash of x is changing sign from positive to negative. So this is your local maximum. Okay, here it is changing sign from negative to positive. So it is local minima. Okay, so now you have to find the value, maximum and minimum. So you have to put this -1 in f of x, not in f dash of x. Okay, f of -1. So -1 cube plus 3 plus 3, 5. Okay. So this is your maximum value, minimum value. Okay. -1 becomes the point of local maxima. 1 becomes the point of local minima. Okay. Same question we'll solve using second derivative test. Okay. So we have got f dash of x. Okay, putting it to equal to 0, you will get x equal to -1, x equal to 1, critical points. Now you have to derive it again. So 3 to the 6, 6, 6. Okay. Now you have to put the points -1. So this is coming less than 0. So this is maxima. That is -1 is the point of maxima. Okay. 1 report you'll get this. It's a point of minima. Okay. Next question. This is the board question. Okay. Find the maximum profit that a company can make if profit function is given by P of x 72 plus 42x minus x square, where x is the number of units and P is the profit in rupees. Okay. So whenever it is asked maximum or minimum, I'll suggest you to go for the second derivative test because that is the easiest one. Okay. First derivative test, it becomes very difficult. You have to see the points, then you have to put it in the f dash of x. So better you go for second derivative. So this function is p of x. Okay, first you find out the first derivative, equate it to 0. Okay, to find x. So x is equal to 21. Okay, now you have to find second derivative. This is your critical point. Okay, second derivative is -2. So we are directly getting it to be -2 without substituting the x. So this is less than 0. So this implies maximum. Okay. So your function is maximum at the point x equal to 21. So now we can find the maximum value. That is, you have to put that x in p of x. Okay. 42 is 21 into 2. Right. So here I can write 21 into 2. What about this? So we can take common 3 square. We'll get inside 8 plus 49 into 2. 98 minus 49. Okay, that is 49. 98 minus 49, again we will get 49. 57. 513. Okay, so the maximum profit is rupees 513.